Hi all. Today we are going to discuss one of the most common production issues faced in Spring Boot applications, that is thread pool exhaustion. This is a problem many developers encounter in real-time systems, especially in banking, e-commerce and microservice-based applications. Sometimes applications suddenly become very slow. APIs stop responding properly. Users start experiencing timeout errors. But when we check the system, CPU usages looks normal. Database also appears healthy. Still the application feels unresponsive. So in this video, we'll understand what thread pool exhaustion actually is, why it happens in production, how to identify it, and how companies solve it in real environments. Let's understand this with a practical production scenario. Suppose a banking application is running smoothly. Suddenly APIs become extremely slow. Requests start waiting for long time. Some users receive timeout errors. Now the support team raises an incident. Developers start checking the system. CPU usage normal. Database health looks fine. Memory that is also stable. But application is still hanging. Then the team restarts the application and everything starts working normally again. After some time, the same issue repeats. This is one of the most common symptoms of thread pool exhaustion in production systems. To understand this issue properly, first we need to understand what a thread is. In simple terms, a thread is a worker inside the JVM. Whenever the request comes to a Spring Boot application, Tomcat assigns one thread. That thread processes the request, executes the business logic, interacts with the database or external services, sends a response back to client, and finally becomes available again. Now the same thread can handle another request. The problem starts when threads are occupied for too long and are not becoming free. Let's take a simple real life example. Imagine a restaurant has only 5 waiters. Suddenly 100 customers arrive. The first 5 customers are served immediately. The remaining customers must wait because no waiter is available. Spring Boot applications work in a very similar way. Here, threads are like waiters. Requests are like customers. If all threads are busy handling requests, new incoming requests must wait. That is when application's performance starts degrading. Now let's understand where these threads actually come from. In Spring Boot applications, we usually use an embedded Tomcat server internally. Tomcat maintains something called a thread pool. You can think of it like a group of workers available to handle incoming requests. By default, Tomcat maintains around 200 worker threads. So whenever requests come, Tomcat assigns available thread to process them. Normally this works completely fine because requests finish quickly and threads become free again. But real problem starts when requests begin taking longer time. For example, database query becomes slow. External API responds very late. Some operation blocks the thread. Now threads remain occupied for longer duration. Slowly more and more threads become busy. Eventually all available threads get occupied. And once that happens, new incoming request must wait until some thread becomes free again. That's when application starts becoming slow in production. Now let's discuss the common reasons behind thread pool exhaustion. One major reason is slow database queries. If a query takes 20 or 30 seconds to execute, the thread remains blocked during the entire operation. Another common reason is external API delay. Suppose our application calls a payment gateway and the external service is slow. Until response comes back, our thread keeps waiting. Other common causes include blocking operations, infinite loops, missing timeout configurations, handling too many concurrent users. All these situations gradually consume available threads. In production environment, the symptoms can sometimes be misleading. Typically, we observe APIs becoming very slow, requests continuously loading, timeout exceptions, sudden increase in response time. One interesting point is CPU usage may still remain normal because threads are waiting or blocked, not actively consuming CPU resources. Another common observation is restarting the application temporarily fixes the issue. Now, the important question is how do companies actually identify this issue in production? One very common approach is thread dump analysis. Using the jstack command, developers take a snapshot of all running threads inside the JVM. This helps identify which threads are blocked, which threads are waiting, which methods are taking too much time, and whether the same operation is getting repeated continuously. In real production environments, companies also use monitoring tools like Grafana, Prometheus, Dynatrace, AppDynamics. These tools help monitor active thread count, response time, JVM health, stuck request. So, instead of randomly restarting the applications, production team first analyze thread behavior properly. Let's look at a simple example. Suppose an API contains thread sleep for 30 seconds. Now every request blocks one thread for 30 seconds. If many users call this API simultaneously, all available threads may become occupied. At that point, new incoming requests cannot get threads immediately, and the application starts appearing slow or unresponsive. Now let's discuss how companies solve this issue. The first step is adding proper timeout configurations. Threads should never wait indefinitely. Second, slow database queries must be optimized. Third, long running operations should be moved to asynchronous processing whenever possible. Fourth, unnecessary blocking operations should be avoided. Modern applications also prefer WebClient instead of RestTemplate because it supports non-blocking communication. One important thing to remember, simply increasing thread count is not the real solution. The actual solution is identifying why threads are getting blocked. In production systems, thread pool configurations are tuned carefully based on traffic. For example, maximum thread count and queue capacity can be increased, but increasing thread count alone is risky because if root cause still exists, additional threads will also become blocked. That is why production engineers focus primarily on root cause analysis. These are some commonly asked interview questions related to this topic. What happens if all Tomcat threads become busy? Why does CPU usage remain normal even when applications become slow? How do you identify blocked threads in production? Why does restarting the application temporarily solve this issue? If you understand the concept we discussed today, answering these questions become much easier. So today we understood every request requires a thread. Threads are limited resources inside the application. Blocking operations can become dangerous in production systems. Slow APIs, slow database queries, and missing timeout configurations can eventually exhaust the thread pool. And finally, restarting the application only fixes the symptom temporarily, not the actual root cause. If you found this video useful, share it with your developer friends and subscribe for more real-world Java and Spring Boot production concepts. More production issues, performance tuning topics, and interview discussions are coming in upcoming videos. Thank you.